So here's another problem to work on for the final exam, number 21, page 740. Problem asks us to find the Maclaurin series. For 3 to the x. So what we need to do is find the coefficients. And the coefficients, a sub k, we derive to be the kth derivative. Excuse me. Evaluated at 0 over k factorial, where the so-called 0th derivative is just the value of the function. So a sub 0 is 3 to the 0 equals 1. And then we need a derivative. F prime of x equals, because it's an exponential function, because the base is not e, we have to kick a natural log out. So there's the derivative, and we're going to plug in 0, which gets me ln 3. And therefore, a sub 1, let's write these in red, is equal to ln 3 divided by 1 factorial. Well, that's just ln 3. Now, the derivatives here are particularly easy. We'll do one more, and then we'll figure it out. Every time we take a derivative, we have this constant times the derivative of 3 to the x, but 3 to the x kicks in ln 3. So those are going to stack up. And if you plug in 0, you get ln 3 squared. Now this is the x squared term, so we divide by 2 factorial, which is just 2. And so we get ln 3 squared divided by 2. And now I think we see the pattern. A sub k is going to be ln 3 to the power k divided by k factorial. And so the Maclaurin series is 1 plus a sub 1 was ln 3 times x. A sub 2 was ln 3 squared over 2 times x squared, and so on. And now the factorials start to matter. Okay, so there it is in sigma form. We can start k at 0. And we see the coefficients are going to be ln 3 to the power k divided by k factorial, and then we have an x to the k. And we could combine the x and the ln 3 to a single power. It doesn't really matter. Like this. So maybe we would write the x first so we know exactly. It's hard to erase. There we go. To the power k over k factorial. So we found the Maclaurin series for 3 to the x. And we know that for x's inside the interval of convergence that this equals the function 3 to the x. And now we should find the radius of convergence. So using the ratio test, I think it's pretty routine. I'm just going to say it, and you can work on it if you're not sure. We actually will get 0 from the ratio test, which tells me that r is infinity. That is, we need less than 1, and it doesn't depend on x. And so it converges for all x. So back to red, there it is, for all x. All right, so there you have it. Problem number 21, page 740. And here's another problem. This is number 13, page 801. So they give us the curve, x equals t minus sine t, and y equals 1 minus cosine t. This curve has a physical description. I think they work it out in the book. I didn't work it out. The videos I've prepared, and I really haven't talked about it much, it's called a cycloid. And it's the curve, just take my word for it. If you fix, like take a bicycle, and where one of its tires touches the ground, identify this point. So here's our bike. All right, and then you push the bike forward. Here's the ground, the x-axis. And if you track this point, it's going to do something like this. Okay, that's called a cycloid. And under certain conditions, we can derive, and it's not actually terribly complicated. That's the curve. That's just for your information. It has nothing to do with this problem. What we want to do here is, and they ask us to find the line tangent to the curve at t equals pi over 6. So that's kind of ugly. At t equals pi over 6. Okay, so for a tangent line, we need the slope of the line, and we need a point. The point is simple. We'll just plug in pi over 6. So the x-coordinate is pi over 6 minus the sine of pi over 6, but we know that's 1/2. So we get pi over 6 minus 1/2. The y-coordinate is 1 minus the cosine of pi over 6, and we know that as well. 1 minus the square root of 3 divided by 2. So there's the point, not the prettiest point around. Pi over 6 minus 1/2. 1 minus the square root of 3 over 2. All right, and now we need the slope. So the slope is dy dx, which for a curve given parametrically is dy dt divided by dx dt, which is dx dt, you can see, is 1 minus cosine t. And dy dt, there's y, is plus sine t. And now let's plug in pi over 6. And we get sine of pi over 6 is 1/2. And we get 1 minus the cosine, that's square root 3 over 2. multiply top and bottom by 2's, and we get 1 over 2 minus the square root of 3. So here's the point. Let's go to red. We know the curve passes through that point, and we know it has this slope. So we should be able to write an equation for it. All right, so here we go. Y minus the y coordinate. Let's do it in red. Right there is the y coordinate. Equals the slope, 1 over 2 minus the square root of 3 times x minus the x coordinate. Gotten this kind of messy. There's the x coordinate. Pi over 6 minus a half. All right, so there is our answer. Not the prettiest thing around, but hopefully true. I suppose we could simplify it, but not much. We'll call that good. All right. So I'll do one more problem. I'm going to make one up. So here it is. Find an integral. Whose value is the length of the curve x equals t squared plus 2, y equals 4t minus 1, from t equals 1 to t equals 4. All right. We haven't studied these curves like scientifically, trying to figure out what's going on. I'll bet you that the graph is a parabola because x has a quadratic relationship and y has a linear relationship. But we don't really need to know that. Really, all we need to know is the formula. So let me write the formula in blue. Arc length is the integral from a to b, the square root of dx dt plus dy dt squared, all with respect to t. So, and since we're just looking for the integral and not the actual value, then this ought to be really easy to do. It's the integral from 1 to 4. We're just told what the t values are, beginning and ending. And then we have the square root dx dt is 2t plus 1. dy dt is 4. So there is our answer. An integral, if we felt like we need to do more with it, we're not asked to evaluate it. We could possibly simplify it, although you can argue that it doesn't really simplify. But if we square that out, we get 4t squared plus 8t, the middle term. That should be a 4t, my bad. Plus 1 plus 16. So if I ask this question on the exam, I think either one of these answers is acceptable. This one is not acceptable for full credit. I mean, it's just the formula. You had it written on your 3x5 card. haven't really shown me, you know, what these symbols mean, dx, dt, dy, dt. So if this is worth 10 points, this gets you 10, this gets you 10, and this probably gets you 5. And you knew the formula, and that's not that big of a deal since you had a note card. But you need to convince me, you know what's going on here, you can take it to the next level. But this guy or that guy, this one or that one, neither one is better than the other. All right, I'll post this, and you have a few more things to look at.